Hello everyone. Today we are going to discuss the concept of modified Euler's method to solve first order ordinary differential equation. As we know, the Euler's method discuss also to solve this type of differential equation, that means the first order differential equation. But what's different in modified Euler's method is in Euler's method we find y1 is equal to y naught plus h into f of x naught comma y naught, and y2 is equal to y1 plus h f of x1 y1, and etc etc. But in Euler's modified method, we have to find y1 so many times, y2 so many times. That means why this is known as, why it is known as the Euler's modified method. Okay, in this method we will get to find y1 more than one times. Okay, so that means what we have to do is y1 is equal to y naught plus h into f of x naught y naught, y we know from Euler's method. And in Euler's modified method, what we do is y1 and this symbol we write here, means the y1 and this one we mention it, that means that indicates the y1 first time. Okay, and that's value is y naught plus h by 2 and the summation of these two functions. What is the function at the values of x and y when the initial values have, and then the next values of x1 y1, that is x1 y1. And what's the y1? Y1 is traditionally as same as the Euler's method. Okay, y1 is equal to y naught plus h into f of x naught y naught, that's it. Okay, so we substitute these two values of that function and then we put here, and then we find the y1 first time. Then we move to the another value of y1 second time, and then what's it? Y0 plus h by 2 and function's value x0 y0 at x0 y0, and then we substitute x1 in this function, and what we find the just the previous value of y1 first time, that we substitute in place of y1 here. Okay, that is the y1 second time. Okay, similarly we find the y1 third time, and in this that is same, 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 and in place of y1 first time we now put here y1 second time, that's value here. Okay, and similarly we repeat this process till we find the y1 n minus 1th time and y1 nth time of the same value. Okay, that's the mistake here, that's the mistake, that is y1 and that is y1. Okay, same should be here, uh, but that's the mistake. So n minus 1 here and n here, that means when two consecutive values of y1 will be same, then we leave it, and that will be the value of y1. Okay, similarly we move to y2. We know from the Euler's method y2 is equal to y1 plus h into f of x1 y1, that is okay. And to obtain y2 from Euler's modified method, what we have to do is y2 first time, that is y1 plus h by 2 function of x1 y1 plus function of x2 y2 here, the first time y1 first time y2 here, and then y2 second time, what is second time y2 is y1 plus h by 2 function of x1 y1 plus function of x2, and in place of y2 we substitute y2 the first time. Okay, that's it. Okay, similarly we find y2 third time, and in place of y that y2 first time we substitute this y2 second time here. Okay, so that's why we find the y2 third time. That means in this process of Euler's modified method we have to keep it in our mind that we have to find the values of y until we will up to that term of y when we find the two equal values of y. Okay, if we get the two equal values of y, then we leave it, and that will be the value of that y. That means if we find the two consecutive y1 are same, then we conclude that's the value of y1. If we get two consecutive values of y2 are same, then we check that value of y2. Okay, and similarly we move to y3, y4, and etc etc up to desired value. Okay, and similarly we can find y2, y3, y4, and etc etc. Okay, and up to desired value. Okay, so that is Euler's modified method. Okay, and in next class we will see an example on Euler's modified method. Okay.